Some machines destroy. Some shape. And some create precision in a single motion. Slow does not mean weak. This machine pushes the long log through the blade and splits it into 4 pieces. A second splitter uses more blades, cutting a shorter log into smaller firewood pieces in one push. Soft material is harder to automate than it looks. The machine has to pull and fold the ribbon without crushing its shape. Then it tightens the center and cuts the ends, turning a loose strip into a finished bow in one short cycle. The real value is repeatability. The same motion, the same shape, again and again. At first, it looks like cutting, but these rollers are pressing the blank into a thread. On a longer rod, the trick is easier to see. The steel is not being shaved away. Pressure squeezes the surface into a continuous spiral. That is why thread rolling works so well in production. Feed the blank, roll the thread, drop the part, and repeat. This is not a hammer blow. The crusher closes slowly, but hydraulic pressure gives the jaws enough force to bite into concrete. The teeth turn that slow force into a sharp bite, cracking the concrete and pulling it away from the steel inside. By the end, the crusher is doing more than breaking concrete. It exposes the steel inside. Once the structure is reduced into smaller pieces, the debris can be cleared, sorted, and recycled much more easily. A pineapple looks simple, but it is hard to peel cleanly. The skin is tough, the body is uneven, and the edible flesh sits right under the surface. That is why the machine has to hold the fruit steady, rotate it, and shave just enough away. Now the same controlled cut is repeated across many pineapples at once. Each fruit has a slightly different shape, but the line still has to peel them evenly. The goal is not only speed, it is speed without wasting too much of the fruit. The tricky part is still hiding under the skin. Pineapple eyes sit deep in the flesh, so the machine removes them one by one while trying to keep as much fruit as possible. It looks like the machine is making a board, but it is doing the opposite. Instead of cutting thick pieces, it shaves the wood into a thin sheet, almost like unwrapping the grain. The value is the surface, a thin veneer sheet that still carries the natural grain. A straight bar looks too simple to become a handle, but the shape is not made in one move. The machine locks the metal in place, then each tool pushes from a different direction until the handle takes shape. Once the angles are set, the machine can repeat the same shape again and again. That is how straight steel turns into matching U-shaped parts in seconds. The surprising part is how small the movements are. Bend by bend, a simple bar becomes handles, brackets, or shaped metal parts. A weld can happen so fast that it almost looks like the nut was simply pressed onto the metal. But the real heat is hidden at the contact point, where pressure and electric current meet. The metal sticks together at one tiny spot so the joint looks small and clean. Nothing solid is touching the steel. The cut starts from a tiny point of light, then slowly grows into a full circle. Now the same beam moves faster across the disc. It cuts the remaining holes one by one, then follows the outer edge. Slowly, the flat round plate starts to look like a gear. No blade carved this shape. The rough disc has become a gear blank through heat, motion, and a narrow beam of light. One mango is not the challenge. The hard part is the whole line. Each fruit has to move, turn, and peel at the same rhythm. Even with different shapes, the skin has to come off without wasting too much flesh. The fruit is still too large and uneven to cut into tiny pieces at once, so the machine first separates it into bigger sections. Then the final blades finish the job, turning those larger sections into small, even mango pieces. Tea harvesting is not just about cutting leaves. The cutter has to skim the young top layer, where the fresh shoots grow. Small blades sweep across the surface, cutting the fresh shoots and guiding them straight into the collection bag. A wider cutter changes the scale. One worker can cover a larger strip of tea while keeping the blade near the young top layer. Each pass cuts and collects more shoots, so the harvest moves much faster. Before the robot can load the truck, the line has to feed each bag into the right position. Bags are harder than boxes. They bend, sag, and shift. So the robot has to control the weight before placing it. The payoff is a stable load. Bag after bag lands in the same pattern, without the same heavy lifting by hand. A CNC carving does not appear in one cut. The machine follows a programmed path, taking away tiny layers of wood until the picture rises from the surface. Smaller passes return to clean the edges and sharpen the depth. The advantage is repeatability. Once the design is programmed, the same carved pattern can be made again on furniture, doors, and decorative panels. This spring is shaped cold. A thick steel wire is pushed forward and bent around fixed tools until each turn becomes part of the coil. The payoff is repeatability. The same wire follows the same path again and again, producing matching springs for heavy-duty equipment. A wide head nail is made from two parts. The machine feeds the steel shank, drops a thin headpiece into position, and presses them together into one fastener. The wide head spreads the holding force, making it useful for roofing, thin sheet materials, and softer surfaces. Not every production step is fully automated. Some work still depends on trained hands, quick timing, and steady coordination. This ring is not cut from a giant plate. A hot steel block is pressed flat, pierced through the center, and moved into the rolling machine while it is still glowing. Once the rollers grip the ring, they squeeze the metal outward. The wall becomes thinner. The diameter grows larger. And the thick blank turns into a formed ring for bearings, flanges, or heavy machinery. This head does more than grab the tree. It cuts through the trunk and controls the fall in one motion. A tree is not ready for transport the moment it falls. The stem is still long, uneven, and covered with bark and branches. The processing head uses rollers and cutting edges to turn that raw shape into shorter, cleaner logs that can be stacked, loaded, and moved out of the forest. The hard part is not filling the liquid. It is giving something shapeless a flexible container before it can spill or deform. Once the seal closes, the pouch becomes stable enough to move down the line like a product, not just a liquid. Laser welding is about concentration, not brute heat. The beam focuses energy into a narrow line, melting the joint while less of the surrounding metal is overheated. That helps leave a cleaner seam with less finishing afterward. The payoff is scale. One mold cycle turns molten plastic into a full chair, not separate pieces. The pattern looks simple, but the timing has to be exact. Each wire is bent and hooked into the one before it, so the mesh grows one link at a time. By the end, loose steel wire has turned into a flexible fence roll ready for transport and installation. A rock crusher does not slice stone apart. It traps each rock and crushes it under heavy force until cracks spread through the material. The result is smaller stone that can be sorted, transported, or used in the next stage of construction. That is how large, uneven rock becomes usable material for roads, concrete, and building foundations. A smooth finish depends on a steady hand. Each pass overlaps the last, building a thin coat that turns a raw part into something ready to use. Labeling is about alignment. Each bottle has to meet the label at the right position. Then rollers press it flat as the bottle moves through the machine. In seconds, a plain container becomes a finished product with its brand wrapped cleanly around the surface. This process does not change the gear's shape. It changes the surface. Induction heating rapidly heats the outer layer, then quenching cools it fast. That creates a harder skin that can resist wear, while the inside stays tougher instead of becoming brittle. The robot is not just pushing mortar around. A laser reference tells it what level the floor should be, while the screed spreads the wet mix into a flatter surface. After leveling, a finishing pass smooths the top so the floor is closer to its final surface. The hidden trick is standardization. Instead of making each toilet roll one by one, the factory first makes a long paper log, then cuts it into equal lengths. That keeps every roll the same size and makes the packaging line easier to control. Hydraulic punching is not drilling. It uses concentrated pressure to shear metal in one stroke. In an automated cycle, the value is repeatability. The machine can place the same holes again and again with the same spacing, without cutting the metal away bit by bit. That matters when a steel part needs several bolt holes because every hole has to line up later with another bracket, frame, or machine base. A motor does not start with magnets alone. Copper wire is wound into tight coils, so electric current can create a magnetic field inside the stator. The cleaner the winding, the more consistent the motor can run. A thick power cable is not stripped in one step. The outer jacket has to be opened first, so the bundle inside can be separated into smaller insulated cores. That staged process matters because the goal is not just to cut the cable, but to recover the copper cleanly for reuse. The useful part is control. A laser can target rust on different metal surfaces without scraping the whole part down. On small parts, it reveals the clean metal underneath. On rebar and larger frames, the same focused energy can clean uneven surfaces without using a grinding wheel. That makes laser cleaning useful when the goal is to remove contamination while keeping more of the base metal intact. A plastic bottle does not start at full size. It begins as a small heated preform, then air pressure expands it inside the mold. In seconds, the plastic stretches outward and locks into the bottle shape. That is how factories turn one small preform into a lightweight container for drinks and other packaging. Some steps still depend on human rhythm. Trained hands can sort, align, and place small parts quickly, making tiny adjustments that a full machine setup may not be worth automating. That keeps the line moving without slowing the process down. A complex tube shape is not made with one bend. The machine has to clamp, rotate, feed, and bend the pipe through a sequence of angles. Each step changes only one part of the tube, but together they turn a straight piece of metal into a finished frame without collapsing the hollow wall. That is why tube bending matters in frames, handles, railings, and fluid lines, where the shape has to be accurate and the tube still has to stay strong. Fruit sorting starts before the grading step. The limes are washed, spread into a single flow, and then guided into the sizing section. Once they reach the sorting drum, each fruit drops into the lane that matches its size, turning a mixed batch into cleaner, more consistent groups. A vibratory bowl feeder does more than shake parts around. Its track and small gates turn a random pile into a clean, one-by-one supply in the right orientation. Packaging is not just the last step. It turns many loose products into one unit that can be counted, stored, stacked, and shipped. The carton gives the load its shape, while tape and straps keep that shape from falling apart on the way to the customer. A pallet is not stable just because boxes are stacked on it. Stretch film turns the stack into one locked load. Each layer adds tension around the sides, so the boxes are less likely to shift during storage, loading, or transport. Soft materials are harder to control than rigid boxes. A blanket can sag, wrinkle, and shift as it moves. The folding line guides the fabric in stages, turning a loose, flexible sheet into a compact shape that is easier to pack, store, and ship. Printing on a curved bowl needs something softer than a flat stamp. The silicone pad deforms as it touches the surface, carrying the ink around the curve and leaving the pattern where a rigid tool could not press evenly. That flexibility is why the same method works on bowls, cups, and other uneven ceramic shapes. A concrete barrier starts as a wet mix, but the mold decides its final shape. Vibration helps the concrete settle into the corners, and the surface is leveled before the piece is turned over. When the mold is opened and lifted away, the real test appears. Clean edges, a solid surface, and one heavy barrier ready for the road. A bearing looks simple from the outside, but inside it is built in layers. The inner and outer rings enter the line separately. Then steel balls are dropped into the gap and spaced around the raceway. The ball spacing looks small, but the shields make the bearings stay together. Which step do you think matters more? The spacing or the shields? When metal shields are pressed on both sides, the loose parts become one compact unit built to reduce friction and keep motion smooth. Hot forging starts before the press even touches the metal. The bar is heated until it glows. Then each section is pushed into the die while it is still soft enough to flow. Instead of cutting the shape out of steel, the machine forces hot metal into form, creating dense parts built for strength. From raw heat to repeated impact, this is where pressure turns metal into something ready to work.